Welcome back, everyone. I'm Thomas, and in today's video, we're continuing our series for the MS AZ-104 exam. We'll be diving into questions 21 through 40. If these breakdowns are valuable to you, you can now support the team directly via Super Thanks. It's never expected, but it helps us create more quality content. Now, let's get right to the key concepts. Question 21. Your company has an Azure Active Directory, Azure AD, tenant named Wayland.com that is configured for hybrid coexistence with the on-premises Active Directory domain. You have a server named DirSync1 that is configured as a DirSync server. You create a new user account in the on-premise Active Directory. You now need to replicate the user information to Azure AD immediately. Solution: you use Active Directory sites and services to force replication of the global catalog on a domain controller. Does the solution meet the goal? A. Yes. B. No. Alright, this question is testing your understanding of the synchronization topology in a hybrid environment. Specifically, it asks you to distinguish between intra-site replication, between local domain controllers, and hybrid synchronization, between your on-premises environment and the cloud. With that context, let's evaluate the options to see if the solution triggers the correct process. Option A, yes, is incorrect. Active Directory sites and services is a tool used to manage the replication topology between your on-premises domain controllers. If you force replication of the global catalog here, you are simply ensuring that domain controller A shares its updates with domain controller B faster than usual. This tool has absolutely no connection to the Azure Ad Connect, formerly DirSync, engine. It does not push any data out to the internet or to the Azure tenant. Option B, no, is the correct answer. The proposed solution fails because it only moves data horizontally within your local network. To force an immediate replication to Azure Ad, you must interact with the synchronization tool itself, DirSync1. In modern versions, Azure Ad Connect, you would use PowerShell to run startad syncing cycle, policy type Delta. In older legacy versions, DirSync, you would use the configuration wizard or a specific PowerShell command to force the run. Manipulating the local global catalog replication does not trigger the cloud synchronization agent to wake up and export the changes. Therefore, because the tool used only affects local servers and not the cloud connector, the goal of updating Azure Ad is not met. The correct solution is B. Question 22. Your company has two on-premises servers named SRV01 and SRV02. Developers have created an application that runs on SRV01. The application calls a service on SRV02 by IP address. You plan to migrate the application on Azure Virtual Machines, VMs. You have configured two VMs on a single subnet in an Azure Virtual Network. You need to configure the two VMs with static internal IP addresses. What should you do? A. Run the new Azure RMVM config PowerShell command. B. Run the set Azure subnet PowerShell command. C. Modify the VM properties in the Azure Management Portal. D. Modify the IP properties in Windows Network and Sharing Center. E. Run the set Azure static VNet IP PowerShell command. Alright, this question is testing your understanding of how IP addressing works in the cloud versus on-premises. Specifically, it focuses on the correct control plane for assigning static IP addresses to Azure Virtual Machines. The key requirement is maintaining specific internal IP addresses so the hard-coded application logic continues to work after migration. With that context, let's evaluate the options to find the correct configuration method. Option A, run the new Azure config PowerShell command, is incorrect. This command is used during the creation phase of a virtual machine object in PowerShell scripts to define its configuration, like size, name, and availability set. It is not used to modify the networking properties of an existing, running virtual machine or its network interface. Option B, run the set Azure subnet PowerShell command, is incorrect. This command targets the subnet itself, e.g., changing the address range or network security group association. You cannot assign a specific static IP to a specific VM by modifying the subnet object. Static IP assignment happens at the network interface, NIC, level, not the subnet level. Option C, modify the VM properties in the Azure Management Portal, is the correct answer. In Azure, the DHCP service is managed by the Azure Fabric, not the OS. To set a static internal IP, you must navigate to the virtual machine's network interface settings in the Azure portal, or use the equivalent PowerShell/CLI commands for the network interface. You change the assignment from dynamic to static and specify the desired IP address there. This tells the Azure SDN, software-defined network, to always reserve that specific address for this VM's interface. Option D, modify the IP properties in Windows Network and Sharing Center, is incorrect and actually dangerous in Azure. In an on-premises environment, this is exactly what you would do. However, in Azure, you should never manually configure the static IP inside the guest OS, Windows/Linux, network adapter settings. If you do this, the Azure Fabric, which thinks the IP is dynamic, might assign that IP to another machine, or the VM might lose connectivity entirely because the platform doesn't know about the change. The IP settings inside the OS must always remain set to obtain an IP address automatically, DHCP, letting the Azure platform inject the static IP you configured in the portal. Option E, run the setazure-static-natip PowerShell command, is incorrect because it is a legacy command from the classic deployment model, ASM, Azure Service Management. The question implies a modern deployment, mentioned by the use of AzureM in other options and the context of modern nets. Using classic commands on ARM, Resource Manager, resources will fail. Therefore, the only safe and correct way to reserve an IP address for a cloud VM is to configure the network interface properties via the Azure Management Tools. The correct solution is C. Question 23. You have 15 Azure subscriptions. You have an Azure Active Directory, Azure AD tenant that contains a security group named Group 1. You plan to purchase additional Azure subscription. You need to ensure that Group 1 can manage role assignments for the existing subscriptions and the planned subscriptions. The solution must meet the following requirements. Use the principle of least privilege. Minimize administrative effort. What should you do? A. Assign Group 1 the owner role for the root management group. B. Assign Group 1 the user access administrator role for the root management group. C. Create a new management group and assign Group 1 the user access administrator role for the group. D. Create a new management group and assign Group 1 the owner role for the group. Alright, this question is testing your ability to manage governance at scale. You have a large number of subscriptions, 15 plus, and more coming. You need a way to apply permissions to all of them at once without having to configure each one individually. This is the perfect use case for Azure Management Groups, specifically understanding how inheritance works from the root level down. With that context, let's evaluate the options to find the solution that balances efficiency with security. Option A, assign Group 1 the owner role for the root management group, is incorrect because it violates the principle of least privilege. While assigning the owner role at the root level would technically allow Group 1 to manage role assignments, since owners can do everything, it also gives them full control to create, delete, and modify every single resource, VMs, databases, storage, across all subscriptions. The requirement is only to manage role assignments, not the resources themselves. Option B, assign Group 1 the user access administrator role for the root management group, is the correct answer. The root management group is the very top of the hierarchy. All existing subscriptions and any future subscriptions you buy will automatically fall under this root, or one of its children. By assigning the permission here, it inherits down to everything, satisfying the minimize administrative effort requirement. Crucially, the user access administrator role is designed specifically to let users manage access, RBAC, without giving them permission to touch the resources themselves. This strictly adheres to the principle of least privilege. Option C, create a new management group and assign Group 1 the user access administrator role for the group, is incorrect due to the administrative effort involved. If you create a new management group, it starts empty. You would then have to manually move all 15 existing subscriptions into this new group for the permissions to take effect. Using the existing root management group avoids this extra work. Option D, create a new management group and assign Group 1 the owner role for the group, is incorrect for both reasons mentioned above. It requires the manual effort of moving subscriptions into the new group, and it grants the excessive owner permission, which violates the security requirements. Therefore, to cover all current and future subscriptions with a single action while granting only the exact permission needed, you must use the root management group with the User Access Administrator role. The correct solution is B. Question 24. You have an Azure subscription named Subscription 1 that contains a virtual network named VNet 1. VNet 1 is in a resource group named RG1. Subscription 1 has a user named User 1. User 1 has the following roles: a reader, security admin, security reader. You need to ensure that User 1 can assign the reader role for VNet 1 to other users. What should you do? A. Remove User 1 from the security reader role for Subscript on 1. Assign User 1 the contributor role for RG1. B. Assign User 1 the owner role for VNet 1. C. Remove User 1 from the security reader and reader roles for Subscription 1. Assign User 1 the contributor role for Subscription 1. D. Assign User 1 the contributor role for VNet 1. Alright, this question is testing your specific knowledge of the differences between the owner and contributor roles in Azure RBAC. The core requirement is finding a role that includes the permission Microsoft authorization/role assignments/right, which is the specific right needed to manage who has access to a resource. With that context, let's evaluate the options to see which role grants this capability. Option A, assign User 1 the contributor role for RG1, is incorrect. While the contributor role is powerful and allows you to create and manage almost all Azure resources, like creating VMS or subnets, it specifically excludes the ability to grant access to others. This is a deliberate security design to prevent standard administrators from taking over a subscription. Therefore, a contributor cannot assign the reader role to anyone. Option B, assign User 1 the owner role for VNet 1, is the correct answer. The owner role is the highest level of access. It includes everything the contributor role has, plus the critical ability to manage user access, authorization. By making User 1 an owner of VNet 1, they gain the right to modify the access control (IAM) settings for that specific virtual network, which allows them to assign the reader role to other users. While User Access Administrator would be a lower privilege alternative, it is not provided as an option here, making owner the only valid choice. Option C, assign User 1 the contributor role for Subscription 1, is incorrect for the same reason as Option A. Even though the scope is larger, the entire subscription rather than just a resource group, the limitations of the contributor role remain the same. A subscription contributor still cannot assign roles to other users. Option D, assign User 1 the contributor role for VNet 1, is incorrect. Just like the other contributor options, this role grants management rights over the virtual network configuration, IP addresses, subnets, peering, but explicitly denies the ability to change permissions. Therefore, among the choices provided, the only role that contains the necessary authorization permissions is the owner role. The correct solution is B. Question 25. You need to move the blueprint files to Azure. What should you do? A. Generate an access key. Map a drive, and then copy the files by using File Explorer. B. Use Azure Storage Explorer to copy the files. C. Use the Azure Import/Export service. D. Generate a shared access signature, SAS. Map a drive, and then copy the files by using File Explorer. Alright, this question is asking for the most appropriate tool to manually transfer files from a local environment to Azure Storage. While the specific type of storage, blob versus file share, isn't explicitly detailed in the snippet, the solution needs to be robust enough to handle standard file operations effectively. With that context, let's evaluate the options to find the best tool for the job. Option A, generate an access key, map a drive, and then copy the files by using File Explorer, is technically possible but limited. Mapping a network drive, SMB mount, only works if the destination is specifically an Azure file share. If the destination is Azure Blob Storage, which is very common for unstructured data like blueprints, you cannot map a native Windows drive to it. Furthermore, mapping a drive requires port 445 to be open outbound, which is blocked by many corporate firewalls, ISPs, making this solution less reliable than tools that use standard web ports. Option B, use Azure Storage Explorer to copy the files, is the correct answer. Azure Storage Explorer is a free, standalone application from Microsoft designed specifically for managing Azure storage data. It works over HTTPS, port 443, so it is firewall-friendly. Crucially, it supports all Azure storage types: blobs, files, queues, and tables. Whether the blueprint files are destined for a blob container or a file share, Storage Explorer provides a familiar drag-and-drop graphical interface to handle the upload efficiently. It is the standard administrative tool for this kind of ad hoc data movement. Option C, use the Azure Import-Export service, is incorrect. This service involves physically shipping hard drives to a Microsoft data center. It is designed for massive offline data transfers, typically terabytes or petabytes, where uploading over the network would take weeks or months. For a standard set of blueprint files, this process is incredibly slow, taking days for shipping and processing, and is completely overkill. Option D, generate a shared access signature, SAS, map a drive, and then copy the files by using File Explorer, is incorrect. As mentioned in Option A, mapping a drive is specific to the SMB protocol used by Azure Files. However, the standard Windows Map Network Drive feature requires the storage account name and the storage account key for authentication. It does not natively support mounting a drive using a SAS token as the password. Therefore, this specific combination of authentication method and connection method is technically invalid for a standard client. Therefore, for a versatile, firewall-friendly, and easy-to-use method to move files to any type of Azure storage, the dedicated tool is the best choice. The correct solution is B. Question 26. You have an Azure subscription that contains a storage account named Storage One. You need to ensure that the access keys for Storage One rotate automatically. What should you configure? A. A backup vault. B. Redundancy for Storage One. C. Lifecycle management for Storage One. D. An Azure Key Vault. E. A Recovery Services Vault. Alright, this question is addressing a critical security best practice: credential hygiene. Leaving the same access key active for months or years increases the risk if that key is ever leaked. The goal is to find the specific Azure service capable of acting as an automation engine to regenerate these keys on a schedule without human intervention. With that context, let's evaluate the options to find the correct automation tool. Option A, a backup vault, is incorrect. A backup vault is a storage entity used by the Azure Backup Service to hold recovery points for newer workloads like Azure Database for PostgreSQL or Azure Disks. It is purely a container for backup data and has no logic to interact with the configuration or security settings of a storage account. Option B, redundancy for Storage One, is incorrect. Redundancy settings, like LRS, GRS, or ZRS, control how many copies of your data exist and where they are physically located to ensure durability against hardware failures. This configuration protects data availability, but it has nothing to do with managing the security credentials or access keys. Option C, lifecycle management for Storage One, is incorrect, though it is a common distractor. In the specific context of Azure Storage, lifecycle management refers to data lifecycle policies, rules that automatically move older files from the hot tier to the cool or archive tier to save money. It manages the aging of the blobs themselves, not the lifecycle, rotation, of the security keys used to access them. Option D, an Azure Key Vault, is the correct answer. Azure Key Vault is the central repository for secrets, keys, and certificates. Crucially, it includes a feature called Managed Storage Account Keys. When you link a storage account to a key vault, the Key Vault takes over the management of the keys. It can automatically contact the Azure Storage Resource Provider to regenerate, rotate, the keys, e.g., every 90 days, and generate active shared access signature, SAS, tokens for your applications to use. This completely automates the security process. Option E, a Recovery Services Vault, is incorrect. Similar to Option A, this resource is the legacy container used for Azure Backup, protecting VMS, SQL databases, and Azure Site Recovery. It is designed for disaster recovery and data restoration, not for secret management or credential automation. Therefore, to implement automated key rotation and centralized security management, you must use the Key Vault service. The correct solution is D. Question 27. You need to ensure that you can grant Group 4 Azure RBAC read-only permissions to all the Azure file shares. What should you do? A. On Storage 2, enable identity-based access for the file shares. B. Recreate Storage 2 and set hierarchical namespace to enabled. C. On Storage 1 and Storage 4, change the account kind type to Storage v2, General Purpose v2. D. Create a Shared Access Signature, SAS, for Storage 1, Storage 2, and Storage 4. Alright, this question is strictly testing your knowledge of the prerequisites for using identity-based authentication with Azure files. Standard Azure file shares use the storage account key for access, which is an all-or-nothing permission. To use granular RBAC, like granting read-only access to a specific group, you must bridge the gap between Azure AD and the SMB protocol. With that context, let's evaluate the options to understand why the identity configuration is the missing piece. Option A, on Storage 2, enable identity-based access for the file shares, is the correct answer. By default, Azure File Shares authenticate connections using the storage account key, NTLM. To enforce Azure RBAC permissions over SMB, the file sharing protocol, the storage account must be able to validate the user's identity against a directory service. You must enable identity-based access on the storage account, which links it to on-premises Active Directory, ADDS, Azure ADDS, or Azure AD Kerberos. Once this feature is enabled, the storage account can understand who Group 4 is and enforce the Storage File Data SMB Share Reader role you assign to them. Without this setting, RBAC assignments for file shares are effectively useless for data access. Option B, recreate Storage 2 and set hierarchical namespace to enabled, is incorrect. The hierarchical namespace feature is used to convert standard blob storage into Azure Data Lake Storage Gen 2, ADLS Gen 2. This is designed for big data analytics and file system semantics on blobs, not for standard SMB file shares. Enabling this would actually prevent you from using traditional Azure Files features in the way intended for general-purpose file sharing. Option C, on Storage 1 and Storage 4, change the account kind type to StorageEv2, General Purpose v2, is incorrect. While General Purpose v2 is the recommended storage type, it is not the specific setting that unlocks RBAC for files. Even on a v2 account, RBAC for SMB will not work until you explicitly enable the identity-based access setting described in Option A. Furthermore, legacy general-purpose v1 accounts do support Azure Files, so the account version itself is rarely the hard blocker for this specific requirement. Option D, create a Shared Access Signature, SAS, for Storage 1, Storage 2, and Storage 4, is incorrect because it uses a completely different security model. A SAS token is a string included in the URL that grants temporary access based on the token settings, not based on the user's identity. Using SAS does not leverage Azure RBAC, role-based access control, or user groups like Group 4. Instead, anyone holding the token can access the files. This fails the core requirement of the question. Therefore, the fundamental requirement to use RBAC with file shares is to integrate the storage account with an identity provider. The correct solution is A. Question 28. You have an Azure directory, Azure AD, tenant named a datum, and an Azure subscription named Subscription 1. A datum contains a group named Developers. Subscription 1 contains a resource group named Dev. You need to provide the Developers group with the ability to create Azure Logic Apps in the Dev resource group. Solution: on Dev, you assign the contributor role to the Developers group. Does this meet the goal? A. Yes. B. No. Alright, this question is testing your understanding of the core built-in roles in Azure RBAC, specifically what the contributor role allows a user to do. The goal is to ensure the developers can create a specific resource, Logic Apps, and you need to determine if the contributor role grants that permission. With that context, let's evaluate the options. Option A, yes, is the correct answer. The contributor role is a broad, powerful role that grants full access to manage all resources within the scope it is assigned. This means a user with a contributor role can create, update, and delete virtual machines, storage accounts, databases, and crucially for this scenario, Logic Apps. The only significant limitation of the contributor role is that it cannot grant access to other users, assign roles. since the requirement is simply to allow the creation of resources. Assigning the contributor role at the resource group level successfully fulfills the request. Option B, no, is incorrect. Selecting no would imply that the contributor role is insufficient for creating resources. Since the definition of the contributor role is literally to allow the management of resources, creation and deletion, the solution works technically. While there are more specific roles available, like Logic App Contributor, that would adhere better to the principle of least privilege, the question simply asks if this solution meets the goal, and technically, it does. Therefore, because the contributor role includes the necessary right permissions to deploy new services, the solution is valid. The correct solution is A. Question 29. You have an Azure subscription named Subscription 1 that contains an Azure virtual machine named VM1. VM1 is in a resource group named RG1. VM1 runs services that will be used to deploy resources to RG1. You need to ensure that a service running on VM1 can manage the resources in RG1 by using the identity of VM1. What should you do first? A. From the Azure portal, modify the managed identity settings of VM1. B. From the Azure portal, modify the access control (IAM) settings of RG1. C. From the Azure portal, modify the access control (IAM) settings of VM1. D. From the Azure portal, modify the policy settings of RG1. Alright, this question is testing your knowledge of managed identities for Azure resources. The scenario describes a classic use case. You have code running on a VM that needs to talk to the Azure Resource Manager, ARM, to create or modify resources. Instead of hard-coding credentials, like a username, password, or service principal secret, into the code, you want the VM to authenticate using its own identity. This process has two distinct steps: creation and assignment. The question asks what you must do first. With that context, let's evaluate the options in order to determine the correct sequence. Option A, from the Azure portal, modify the managed identity settings of VM1, is the correct answer. Before a VM can have an identity to assign permissions to, that identity must exist. By modifying the identity blade of the VM and switching the status to on, for a system-assigned managed identity, you tell Azure to create an identity object in Azure AD that is strictly tied to the lifecycle of that specific VM. Without this step, there is no identity of VM1 to assign roles to. This is the foundational prerequisite. Option B, from the Azure portal, modify the access control (IAM) settings of RG1, is incorrect as a first step. While this is definitely the second step, assigning the contributor role to the VM's identity so it can manage RG1, you cannot perform this action yet. If you haven't enabled the managed identity on the VM, option A, the VM's identity object simply doesn't exist in the directory. You wouldn't be able to find VM1 in the list of users/principals to assign the role to. Option C, from the Azure portal, modify the access control (IAM) settings of VM1, is incorrect. This would involve assigning someone else permission to manage the VM itself, e.g., letting a user restart VM1. The goal is the opposite. We want the VM to manage other resources. Therefore, changing permissions on the VM object itself is irrelevant to the goal of giving the VM an outbound identity. Option D, from the Azure portal, modify the policy settings of RG1, is incorrect. Azure policies are used to enforce rules and compliance, like restricting VM sizes or locations. They do not handle authentication or identity creation. Configuring policies would not help the VM authenticate to Azure AD. Therefore, the logical workflow is 1. Create the identity, enable managed identity, then 2. Grant the identity access, RBAC assignment. Since the question asks what to do first, you must start with the identity creation. The correct solution is A. Question 30. You have an Azure DNS zone named adatum.com. You need to delegate a subdomain named research.adatum.com to a different DNS server in Azure. What should you do? A. Create an NS record named research in the adatum.com zone. B. Create a PTR record named research in the adatum.com zone. C. Modify the SOA record of adatum.com. D. Create an A record named star.research in the adatum.com zone. Alright, This question is testing your understanding of DNS hierarchy and how delegation works in the domain name system. Delegation is the process of handing off authority for a specific subdomain, like research.adatum.com, to a different set of name servers. This allows a separate team or a different DNS zone to manage that specific slice of the namespace independently from the parent. With that context, let's evaluate the options to find the correct record type for delegation. Option A, create an NS record named research in the adatum.com zone, is the correct answer. In DNS, an NS name server record is used specifically to identify the authoritative servers for a zone. To delegate a subdomain, you create an NS record in the parent zone, adatum.com, with the name of the subdomain, research. The value of this record points to the name servers that will be responsible for hosting the child zone, research.adatum.com. This effectively tells any DNS resolver, I don't have the answers for research.adatum.com, but these specific servers over here do. Option B, create a PTR record named research in the adatum.com zone, is incorrect. A PTR pointer record is used for reverse DNS lookups mapping an IP address back to a hostname. It is primarily used in reverse lookup zones, e.g., in -address.arpa, not in standard forward lookup zones like adatum.com. It has no function in delegating subdomains. Option C, modify the SOA record of adatum.com, is incorrect. The SOA, Start of Authority, record contains administrative information about the zone itself, such as the primary name server, the email of the administrator, and refresh timers. While every zone has an SOA record, you do not modify the parent's SOA record to create a child zone. Instead, the child zone will eventually have its own SOA record once it is created, but the act of delegation happens via NS records in the parent. Option D, create an A record named star.research in the adatum.com zone, is incorrect. An A address record maps a hostname to an IPv4 address. A wildcard A record, like star.research, would simply answer queries for any host ending in .research.adatum.com with a specific IP address. This is not delegation, this is just standard resolution. Delegation implies handing over control to a different name server, not just resolving names to IPs within the existing zone. Therefore, to establishing the referral or link required for delegation, the name server NS record is the mandatory mechanism. The correct solution is A. Question 31. Your company has virtual machines, VMs, hosted in Microsoft Azure. The VMs are located in a single Azure virtual network named VNet1. The company has users that work remotely. The remote workers require access to the VMs on VNet1. You need to provide access for the remote workers. What should you do? A. Configure a site-to-site, S2S, VPN. B. Configure a VNet to VNet VPN. C. Configure a point-to-site, P2S, VPN. D. Configure direct access on a Windows Server 2012 server VM. E. Configure a multi-site VPN. Alright, this question is testing your knowledge of Azure VPN gateway configurations and specifically which connectivity method is appropriate for individual remote users. The key phrase here is remote workers, implying individuals connecting from various locations, like home or a coffee shop, rather than a fixed corporate office. With that context, let's evaluate the options to find the correct connection topology. Option A, configure a site-to-site, S2S, VPN, is incorrect. A site-to-site VPN is designed to connect an entire on-premises network, like a headquarters or branch office, to an Azure virtual network. It requires a compatible VPN device, hardware or software, with a public IP address at the on-premises location. Remote workers usually do not have access to enterprise-grade VPN hardware at their homes and need a solution that works directly from their laptops. Option B, configure a VNet to VNet VPN, is incorrect. This connection type is specifically used to bridge two different Azure virtual networks together, allowing VMS in one VNet to talk to VMS in another. It is not used for connecting external users or devices to Azure. Option C, configure a point-to-site, P2S VPN, is the correct answer. A point-to-site VPN is designed specifically to allow individual client computers to establish a secure tunnel to an Azure virtual network. It works by installing a VPN client on the remote worker's device, laptop, or desktop. When the user needs access, they initiate the connection from their machine, creating a secure point, the laptop, to Site, Azure link. This satisfies the requirement for remote workers to access VMS without needing a physical office infrastructure. Option D, configure direct access on a Windows Server 2012 server VM, is incorrect. Direct access is a legacy remote access technology that requires significant infrastructure setup, including Active Directory domain joining and specific server configurations. While it technically allows remote connectivity, setting up a dedicated VM to manage this is complex, requires maintenance, patching the OS, and is generally considered outdated compared to the native, managed Azure VPN gateway service. Option E, configure a multi-site VPN, is incorrect. A multi-site VPN is simply a variation of the site-to-site VPN that connects multiple physical on-premises locations, like a headquarters and several branch offices, to a single Azure VNet. Like Option A, it connects physical sites, not individual roaming users. Therefore, to support individual users connecting from the public internet, the point-to-site configuration is the standard solution. The correct solution is C. Question 32. Your company has an Azure Active Directory, Azure AD, subscription. You need to deploy 5 virtual machines, VMs, to your company's virtual network subnet. The VMs will each have both a public and private IP address. Inbound and outbound security rules for all of these virtual machines must be identical. Which of the following is the least amount of network interfaces needed for this configuration? A. 5. B. 10. C. 20. D. 40. Alright, this question is testing your understanding of the relationship between Azure Virtual Machines, network interfaces, NICs, and IP configurations. Specifically, it checks if you know whether a single network interface can handle both public and private connectivity simultaneously. With that context, let's evaluate the options to determine the minimum hardware requirement. Option A, 5, is the correct answer. In Azure, a single network interface, NIC, is capable of holding multiple IP configurations. A standard NIC is assigned a private IP address from the virtual network subnet by default. Crucially, you can associate a public IP address object directly to that same IP configuration on the same NIC. This means a virtual machine does not need one card for the internal network and a second card for the internet. Since you have 5 VMS, and each VM requires a minimum of 1 NIC to function, the total count is simply 1 NIC per VM, resulting in 5 network interfaces. Option B, 10, is incorrect. This answer assumes that you need a dedicated network interface for the private IP and a separate, dedicated interface for the public IP. This is a common misconception coming from older physical networking concepts where you might physically separate traffic on different cables. In Azure's software-defined networking, a single interface handles both traffic streams logically. Option C, 20, is incorrect. This suggests deploying 4 interfaces per VM, which is unnecessary and would significantly increase the complexity and cost of the deployment without any technical benefit for the scenario described. Option D, 40, is incorrect. This suggests 8 interfaces per VM. While Azure VMS do support multiple NICs, depending on the VM size, creating this many interfaces is not required for basic public/private connectivity and violates the requirement to find the least amount needed. Therefore, because a single NIC can dual home a private and public IP address, you only need 1 interface for each of the 5 virtual machines. The correct solution is A. Question 33. You have 2 Azure subscriptions named Sub1 and Sub2. An administrator creates a custom role that has an assignable scope to a resource group named RG1 in Sub1. You need to ensure that you can apply the custom role to any resource group in Sub1 and Sub2. The solution must minimize administrative effort. What should you do? A. Select the custom role and add Sub1 and Sub2 to the assignable scopes. Remove RG1 from the assignable scopes. B. Create a new custom role for Sub1. Create a new custom role for Sub2. Remove the role from RG1. C. Create a new custom role for Sub1 and add Sub2 to the assignable scopes. Remove the role from RG1. D. Select the custom role and add Sub1 to the assignable scopes. Remove RG1 from the assignable scopes. Create a new custom role for Sub-2. Alright, this question is testing your understanding of Azure custom roles and specifically how assignable scopes define where a role can be used. The core concept here is that a role definition is a global object within an Azure AD tenant, but it can only be seen and assigned within the specific scopes listed in its definition properties. With that context, let's evaluate the options to find the most efficient solution. Option A. Select the custom role and add Sub-1 and Sub-2 to the assignable scopes. Remove RG1 from the assignable scopes is the correct answer. A single custom role definition can be shared across multiple subscriptions within the same Azure AD tenant. By modifying the assignable scopes property of the existing role to include the root IDs of both subscriptions, /subscriptions/sub1 ID and /subscriptions/sub2 ID, you instantly make that role available for assignment to any resource group within those subscriptions. Removing RG1 is just cleanup, as including the parent subscription automatically covers all its child resource groups. This achieves the goal with a single modification to one object, perfectly satisfying the minimize administrative effort requirement. Option B. Create a new custom role for Sub-1. Create a new custom role for Sub-2. Remove the role from RG1 is incorrect. This approach creates unnecessary duplication. You would end up with two identical role definitions that have to be maintained separately. If you needed to update permissions later, you'd have to do it twice. This is high administrative effort. Option C. Create a new custom role for Sub-1 and add Sub-2 to the assignable scopes. Remove the role from RG1 is incorrect. While this would technically work, creating a new role that spans both, it is inefficient because you are creating a new object rather than simply updating the existing one that is already mostly configured. It adds extra steps compared to Option A. Option D. Select the custom role and add Sub-1 to the assignable scopes. Remove RG1 from the assignable scopes. Create a new custom role for Sub-2 is incorrect. This is a hybrid of the correct and incorrect approaches. It correctly updates the existing role for Sub-1 but unnecessarily creates a duplicate role for Sub-2. As established in Option A, one role can service multiple subscriptions simultaneously, so the second role is redundant clutter. Therefore, the most direct and efficient path is to simply broaden the scope of the existing role to cover both target subscriptions. The correct solution is A. Question 34. You have an Azure subscription that contains the resources shown in the following table. You need to assign Workspace 1 a role to allow read, write, and delete operations for the data stored in the containers of Storage 1. Which role should you assign? A. Storage Account Contributor. B. Contributor. C. Storage Blob Data Contributor. D. Reader and Data Access. Alright, this question is testing your ability to distinguish between control plane roles, management, and data plane roles, accessing content within Azure Storage. The key requirement here is to allow a resource, Workspace 1, to specifically interact with the data, blobs, inside the containers reading, writing, and deleting files. With that context, let's evaluate the options to find the role that grants data-level access. Option A, Storage Account Contributor, is incorrect. This is a management role. It allows you to manage the storage account itself, e.g., change replication settings, rotate keys, update network rules, but it explicitly does not grant access to the data inside the blobs or queues, unless you use the keys to get access, which is a different mechanism. It operates on the control plane, not the data plane. Option B, Contributor, is incorrect for the same reason. The generic contributor role grants full access to manage all resources, but like the storage account contributor, it does not inherently grant permissions to read or write the actual data stored within the blobs. It allows you to manage the container metadata, but not the content inside. Option C, Storage Blob Data Contributor, is the correct answer. This role is specifically designed for the data plane. It grants read, write, and delete access to Azure Storage Blob containers and data. When a service like Azure Synapse Workspace needs to perform ETL operations, extract, transform, load, on files in a data lake or blob storage, this is the precise role required to give it permission to modify the files without giving it administrative control over the storage account settings. Option D, Reader and Data Access, is incorrect. While the Reader and Data Access role sounds promising, it is actually limited. It allows viewing the resource properties, reader, and potentially accessing data via keys, but it is not the standard role for granting granular read/write/delete permissions on blobs to a managed identity. Furthermore, Storage Blob Data Contributor is the more specific and least privileged role tailored exactly for the read/write/delete requirement on blob data. Therefore, to grant the specific ability to manipulate the data files themselves, you must use the dedicated data plane role. The correct solution is C. Question 35. You need to implement a backup solution for App 1 after the application is moved. What should you create first? A. A recovery plan. B. An Azure backup server. C. A backup policy. D. A recovery services vault. Alright, this question is testing your understanding of the fundamental architecture of Azure Backup. Before you can configure policies, schedules, or plans, you need a secure container to store the backup data and manage the service configuration. With that context, let's evaluate the options to find the prerequisite resource. Option A, a recovery plan, is incorrect. A recovery plan is a feature of Azure Site Recovery, ASR, not strictly Azure Backup. It acts as an orchestration script to define the order in which machines fail over and start up during a disaster. You cannot create a recovery plan without first having the infrastructure, the vault, in place to manage the items you are planning to recover. Option B, an Azure Backup Server, is incorrect. Azure Backup Server, MABS, is a specialized on-premises software component used to protect on-premises workloads, like VMware VMS or physical servers, to Azure. If App 1 is being moved to Azure as an Azure VM or web app, you typically use the native Azure Backup Service, not a separate backup server. Even if you did need MABS, you would still need to create a vault in Azure first to register the server against. Option C, a backup policy, is incorrect. A backup policy defines when backups happen and how long they are kept, retention. However, a policy cannot exist in a vacuum. It must live inside a vault. You literally cannot click Create Policy until you have navigated inside a Recovery Services Vault or Backup Vault. Option D, a Recovery Services Vault, is the correct answer. The Recovery Services Vault is the logical container that stores the backup data, recovery points, and houses the backup policies. It is the absolute first step in setting up backup for almost any Azure resource, VMS, SQL, files. You create the vault, and then inside that vault, you define your policies and select the items, like App 1, to protect. Without the vault, there is nowhere for the backup data to go. Therefore, the foundational resource required to enable any backup operations is the vault itself. The correct solution is D. Question 36. You have a Microsoft Entra tenant. You plan to perform a bulk import of users. You need to ensure that imported user objects are added automatically as the members of a specific group based on each user's department. The solution must minimize administrative effort. Which two actions should you perform? Each correct answer presents part of the solution. Note, each correct selection is worth 1 point. A. Create groups that use the assigned membership type. B. Create an Azure Resource Manager, ARM, template. C. Create groups that use the dynamic user membership type. D. Write a PowerShell script that parses an import file. E. Create an XML file that contains user information and the appropriate attributes. F. Create a CSV file that contains user information and the appropriate attributes. Alright, this question is testing your ability to combine two separate Azure administration concepts: bulk user creation and dynamic group automation. The goal is to set up a system where you simply upload a list of users, and Azure automatically routes them into the correct teams without you having to manually click Add Member for each one. With that context, let's evaluate the options to find the two halves of this solution. Option A, create groups that use the assigned membership type, is incorrect. Assigned membership means an administrator must manually select which users belong in the group. If you imported 1,000 users, you would then have to manually find and add them to the group. This violates the requirement to minimize administrative effort and ignores the automatic requirement. Option B, create an Azure Resource Manager, ARM template, is incorrect. ARM templates are used for deploying Azure infrastructure resources, like VMs, storage accounts, VNETs. While you can technically deploy some Azure AD settings via code, ARM templates are not the standard tool for performing a bulk user import operation into Microsoft Entra ID. Option C, create groups that use the dynamic user membership type, is the first correct answer. This addresses the added automatically part of the requirement. By creating a dynamic group with a rule like user.department EQ sales, the system will automatically scan all users in the directory. As soon as the new users are imported with sales listed as their department, the dynamic group engine picks them up and adds them to the group instantly. This requires zero ongoing effort from the admin. Option D, write a PowerShell script that parses an import file, is incorrect because it is unnecessary effort. While PowerShell is a valid way to create users, writing a custom script to parse a file and assign attributes is more administrative effort than using the built-in bulk create feature in the portal, which acts as a wizard for this exact process. The question asks for the solution that minimizes effort, so native tools are preferred over custom coding. Option E, create an XML file that contains user information and the appropriate attributes, is incorrect. Microsoft Entra ID's bulk import feature does not support XML files. It specifically requires comma-separated values, CSV, files. Option F, create a CSV file that contains user information and the appropriate attributes, is the second correct answer. This addresses the bulk import part of the requirement. To add users in bulk via the Microsoft Entra portal or PowerShell, you must provide the data in a structured CSV format. Crucially, this CSV must contain the appropriate attributes, specifically the department column. If you populate the department column in the CSV, the dynamic group, created in Option C, will have the data it needs to automatically sort the users. Therefore, the strategy is 1. Prepare the data with the correct attributes, CSV, and 2. Set up the listener to catch that data, dynamic group. The correct solutions are C and F. Question 37. You have a registered DNS domain named contoso.com. You create a public Azure DNS zone named contoso.com. You need to ensure that records created in the contoso.com zone are resolvable from the Internet. What should you do? A. Create NS records in contoso.com. B. Modify the SOA record in the DNS domain registrar. C. Create the SOA record in contoso.com. D. Modify the NS records in the DNS domain registrar. Alright, this question is testing your understanding of how the public DNS system works, specifically the relationship between a domain registrar, where you bought the name, like GoDaddy or Namecheap, and the DNS hosting service, in this case, Azure DNS. When you create a DNS zone in Azure, it's effectively an isolated island until you connect it to the rest of the Internet. With that context, let's evaluate the options to find the crucial linking step. Option A, create NS records in contoso.com, is incorrect. When you create a new Azure DNS zone, Azure automatically creates the NS, name server, records inside that zone. These records list the 4 Azure name servers, e.g., NS1-01, Azure-DNS.com, etc., assigned to your zone. While these records exist inside Azure, the rest of the Internet doesn't know about them yet. Adding more NS records inside the zone itself doesn't solve the external discovery problem. Option B, modify the SOA record in the DNS domain registrar, is incorrect. The registrar does not hold the SOA, Start of Authority, record for your zone. The hosting provider, Azure DNS, does. You generally do not modify SOA records at the registrar level. The registrar's job is simply to point to the correct name servers. Option C, create the SOA record in contoso.com, is incorrect. Similar to Option A, Azure DNS automatically creates a valid SOA record for you the moment you create the zone. You do not need to create it manually, and creating it wouldn't help the Internet find your zone anyway. Option D, modify the NS records in the DNS domain registrar, is the correct answer. This is the delegation step. Right now, the global DNS system knows you own contoso.com because it's registered, but it doesn't know where the DNS records live. To fix this, you must log into your registrar's portal and replace their default name servers with the 4 specific Azure name servers assigned to your new zone. This tells the Internet, if you are looking for contoso.com, go ask these Azure servers. Without this update, queries will never reach your Azure DNS zone. Therefore, to bridge the gap between your domain registration and your Azure DNS zone, you must update the pointers, NS records, at the registrar. The correct solution is D. Question 38. Your company's Azure subscription includes two Azure networks named Virtual Network A and Virtual Network B. Virtual Network A includes a VPN gateway that is configured to make use of static routing. Also, a site-to-site VPN connection exists between your company's on-premises network and Virtual Network A. You have configured a point-to-site VPN connection to Virtual Network A from a workstation running Windows 10. After configuring virtual network peering between Virtual Network A and Virtual Network B, you confirm that you are able to access Virtual Network B from the company's on-premises network. However, you find that you cannot establish a connection to Virtual Network B from the Windows 10 workstation. You have to make sure that a connection to Virtual Network B can be established from the Windows 10 workstation. Solution: you download and reinstall the VPN client configuration package on the Windows 10 workstation. Does the solution meet the goal? A. Yes. B. No. Alright, this question is testing your detailed knowledge of how point-to-site P2S VPN clients handle routing updates. The core issue here is that the network topology changed, a new VNet peering was added, after the VPN client was initially installed on the user's machine. With that context, let's evaluate the options to see if the solution fixes the connectivity path. Option A, yes, is the correct answer. When you generate and install a P2S VPN client configuration package, it hardcodes the routing table for the VPN connection based on the state of the network at that exact moment. It tells the Windows 10 machine, send traffic for VNetA's address range through this tunnel. When you later peer VNet A with VNet B and enable Gateway Transit, VNet A now knows how to route to VNet B. However, the existing VPN client on the user's laptop does not automatically know about this new route. It still only sends traffic for VNet A through the tunnel. Traffic for VNet B is likely being dropped or sent out the local internet. To fix this, you must download the VPN client package again. The new package will contain the updated routes, including NetB's address range. Once you reinstall it, the Windows 10 machine learns that traffic for VNet B should also go through the VPN tunnel, successfully establishing connectivity. Option B, no, is incorrect. Selecting no implies that reinstalling the client won't solve the routing issue. However, in Azure P2S VPNs, the client configuration is static. It does not dynamically learn routes via BGP or other protocols like a site-to-site connection might. Therefore, manually updating the client by reinstalling the package is the standard and required procedure whenever the back-end network topology changes, like adding a peering link or a new subnet. Therefore, because the client needs the updated routing table to know about the new peered network, reinstalling the package is the correct solution. The correct solution is A. Question 39. Your company's Azure subscription includes Azure Virtual Machines, VMs, that run Windows Server 2016. One of the VMs is backed up every day using Azure Backup Instant Restore. When the VM becomes infected with data encrypting ransomware, you decide to recover the VM's files. Which of the following is true in this scenario? A. You can only recover the files to the infected VM. B. You can recover the files to any VM within the company's subscription. C. You can only recover the files to a new VM. D. You will not be able to recover the files. Alright, this question is testing your knowledge of the file recovery capabilities within Azure Backup, specifically regarding where you can mount the recovery point to extract data. The scenario describes a ransomware attack, which usually implies you want to carefully extract clean files without necessarily restoring the entire compromised OS immediately or interacting directly with the infected machine if it's isolated. With that context, let's evaluate the options to see which recovery path is valid. Option A, you can only recover the files to the infected VM, is incorrect. While you can mount the recovery volume on the source, infected machine, you are not forced to. In a security scenario like ransomware, the source machine might be quarantined, turned off, or deleted. Azure Backup allows you to run the recovery script on a different machine to safely inspect and extract the files. Option B, you can recover the files to any VM within the company's subscription, is the correct answer. The file recovery process in Azure Backup works by mounting the recovery point as a local drive via ISCSI on a machine. You download a script from the Azure portal and run it on a target machine. Crucially, this script can be run on any Windows machine that has internet access to Azure and meets the OS requirements, Windows Server 2016 in this case, provided it is in the same region or has access via peering/connectivity. It does not have to be the original VM. This flexibility allows you to spin up a clean recovery VM, mount the backup of the infected server as a drive E, copy the clean data off, and then discard the connection. Option C, you can only recover the files to a new VM, is incorrect. This confuses file recovery with VM restore. If you were restoring the entire virtual machine, you often choose between replacing the existing one or creating a new one. However, for granular file recovery, you are just mounting a virtual drive. You can do this on an existing admin VM, a new VM, or even the original VM. You are not restricted only to a new one. Option D, you will not be able to recover the files, is incorrect. Ransomware encrypts the live data on the disk. It does not encrypt the historical recovery points stored securely in the Azure Recovery Services Vault, unless the attacker also gained access to your Azure portal and deleted the backups. Azure Backup is specifically designed to protect against this scenario. Instant restore snapshots are read-only and allow for quick recovery of the data state prior to the infection. Therefore, because the file recovery mechanism uses a portable executable script that establishes an ISCSI connection, it can be run on any compatible VM in your environment. The correct solution is B. Question 40. You have an Azure subscription named Subscription 1 that contains an Azure Log Analytics workspace named Workspace 1. You need to view the error events from a table named Event. Which query should you run in Workspace 1? A. Select asterisk from event where event type equals error. B. Event search error. C. Event where event type is error. D. Get event where $_event type equals error. Alright, this question is testing your familiarity with the Kusto query language, KQL, which is the native language used by Azure Log Analytics and Azure Sentinel. You need to recognize the specific syntax structure, which relies heavily on the pipe character, to pass data from one step to the next. With that context, let's evaluate the options to identify the valid KQL syntax. Option A, select asterisk from event where event type equals error, is incorrect because this is standard SQL, structured query language, syntax. While KQL shares some logic with SQL, the syntax is fundamentally different. In KQL, you do not use select asterisk from. Instead, you start with the table name. Azure Log Analytics will not recognize this command. Option B, event search error, is the correct answer. This follows the standard KQL structure. Table name operator. The search operator is a legitimate, broad function in KQL that scans all columns in the table for the specified text string. While using a specific where clause is often more efficient for performance, search is a perfectly valid command to quickly find any rows containing the word error, satisfying the requirement to view error events. Option C, event where event type is error, is incorrect. While it attempts to use the KQL pipe structure, the syntax within the clause is wrong. KQL does not use the word is as a comparison operator. To check for equality in KQL, you must use equals for case sensitive or equals for case insensitive. Therefore, this query would result in a syntax error. Option D, get event where $_event type equals error, is incorrect. This is a PowerShell command, easily identifiable by the get, verb, and the $_ variable syntax. You cannot run direct PowerShell scripts inside the Azure Log Analytics query window. It is an interface strictly for running KQL queries against the log database. Therefore, option B is the only choice that represents valid, executable Kusto query language syntax. The correct solution is B. And that covers everything for today's video. If you found this explanation meaningful, please share it with your friends or colleagues. It helps us build a really strong learning community together. Don't forget to subscribe or check out the other videos in this playlist. Happy learning!